Hi everyone, I'm Abdullah here with Vishal. We work on AI data infrastructure, and today we will talk about Cypher on Velox, a query layer we built to power agent memory, graph rag, and hybrid retrieval use cases. As far as we know, this is the first system that repurposes Velox for federated query execution. Here's how the next 15 minutes flow. I will take the query layer and architecture. Vishal will talk about the graph rag and agent memory and their use cases. Three distinct AI workloads you see here, and not one of them has a database that fully answers the query shape they need. Agents and co-pilots need memory that outlines a single session and can be joined with structured context, not just similar text. Knowledge graphs these days routinely run into billions of nodes, and traversal still has to stay cheap at that scale. Graph rag and hybrid retrieval pipelines are drowning in glue code. The query shape should be expressible natively, not stitched together by hand across three systems. And you see like a same missing primitive across all three, and it breaks down into 4 retrieval needs. Here are the retrieval needs, each with the store it lives in today, and that what that store is missing. Vector DBs, for example, are fast at semantic recall, but they cannot walk a relationship. Graph DBs are great at traversal, but their vector support is weak. Analytics engines handle structured reasoning well, but offline in batch, they are not serving latency. Relational DBs handles exec filters and joins over structural fields cleanly, but only as a post filter on results from another store. That wastes the retrieval work you already paid for. So there is no single store that does all 4. So we built one query layer that does. Cypher says what you want. Axiom figures out how, and Velox makes it fast. So what's Cypher? Cypher is the de facto query language for graphs nowadays in the industry, and ISO GQL, the first international graph query standard, is built on it. The model is simple. You draw the pattern, and the engine finds the subgraphs. If you look at the query example, this single query does semantic similarity, finds the shortest path, and ranks by both. So overall, 1 pattern, 3 retrieval modes you see in a single query. And it's everywhere. In cloud graph DBs, embedded ones, and every major AI framework. Wherever graph data lives, Cypher is the common dialect. So Cypher already won the language layer for us. The next question we needed to answer was how to execute it at meta scale. And over storage we don't own. So this is the resulted architecture we come up with. And as you see, Cypher comes in through multi-language clients for reads and writes. Antler grammar parses it into abstract syntax tree. Next comes the extensibility layer that exposes graph algorithms, vector search, temporal queries, and hybrid scans as procedures. So all of them compose into a single plan. Plan translation lowers the logical plan with graph patterns written as joins and hands it to Axiom. Meta's cost-based optimizer for Velox we use for join reordering, predicate pushdown, and cardinality-based planning. The physical plan runs on Velox, and at these we have pluggable connectors reaching graph stores, knowledge graphs, relational and vector indexes. Spanning every layer, you see like our platform services like schema, lifecycle, caching, and observability. Privacy is also enforced at the plan layer. Policies compile into plan predicates, so they can't be rewritten around. So Velox didn't need to become a graph engine to solve our problems. the graph layer compiles down to Velox. And why Velox? 4 reasons Velox was the right framework for us. Yeah, first, vectorized execution. Velox is columnar and sim-friendly. So graph rows reuse the same analytics operators at runtime. We get a throughput for free. Second, plan infrastructure. Joins, filters, aggregations. Every graph pattern we care about is already a Velox operator. We didn't add new ones. And third, federation through the connector model. Pluggable storage, any backend behind one plan. We don't own the data and we don't want to. And fourth is like the memory and resource management, like pool spilling, back pressure, which are better tested at meta scale. We didn't want to really rebuild. So yeah, 4 wins from Velox, and not one required a fork. That was the key for us. You see supported backends in different categories. So same query language, same plans, whether we are hitting a billion node, billion user graph in production, or SQLite file on agent's laptop. And second layer, like Prism and Hive handle analytical and bulk graphs. XDB, MySQL give us native vector on SQL on relational DB. And graph and vector co-located in one query, no federation needed. And for embedded, SQLite for 0 infra agents, and for prototypes, PhaseDB for hybrid vector, text, and recency search. Adding a new backend is mostly an interface implementation now for us, no engine fork required. That's the query layer story. I will hand it over to Vishal, who will walk you through how this powers GraphRack and agent memory use cases.
Okay, thank you, Abdullah. Hey, everyone, I'm Vishal. In the first half, Abdullah showed you what Cypher is and how we built on Velox. So next, I'll talk about 2 problem domains that are essential for AI systems, and we'll look at how these are applicable over there. So let's start with GraphRack. I'm sure you've all heard of RAG, right? Retrieval Augmented Generation. It's basically a way to ground LLM responses in real data at query time. Now, the problem with RAG is that it treats docs as just isolated chunks. It knows what is similar, but it doesn't know what is connected. This is where GraphRack comes in, right? So GraphRack can traverse relationships and help you answer questions like, who owns the services that were involved in this incident, right? So it can track the owners that way. So GraphRack solves that by adding a graph structure on top of different data that is semantic, you have semantic understanding about, right? And this is where Cypher comes in, because Cypher that we built on Velox lets you express graph plus vector in one query without additional glue code required. So we see like recurring patterns in GraphRack, right? There are multiple use cases. There are some graph native patterns. There are hybrid patterns, right? In graph native patterns, we can talk about multi-hop retrieval. So you can ask questions like find postmortems about services that depend on platform X, right? There are other graph patterns that can span into service intelligence, explainability, and there are other hybrid patterns that show up like when you require constraint-aware filtering, you require signal re-ranking or personalization. So all of these patterns require a similar query shape to recall semantically, walk relationships, and filter by constraints and then rank them. Okay, so one way to think about these patterns is find, traverse, and expand, right? And this is where Cypher can help you think like this. So when you're doing a find, you're doing a precise multi-signal retrieval. So when you ask questions like which services are mentioned in this auth failure incident, so you're going in with a semantic understanding of what that auth failure means. It could be login, it could be some other semantic term that's used. So this is going into vector search. It's doing a text search plus vector search, but it can also have a recency factor into it to boost the ranking. Next, you can traverse and you can add, you can traverse a relationship and add to that question to say who owns these services, right? So that's a 2-hop traversal on top of your semantic search, which is document, to service entity to the owning team. And you can continue to expand it further to ask broad questions, which involve multi-hop neighborhood discovery. So you can ask it questions like, a Ceph fired, what's the blast radius, right? OK, so that was GraphRag. Another problem domain that has emerged is agent memory, right? It's the persistent memory that enables agents' intelligence. So the expectation that you have from agent when you're interacting with it is that gives you session continuity. It has access to a knowledge graph that it can access while talking to you. And it has adaptive learning. So as you interact with the agent more, it produces even better interactions, right? So when an agent operates for hours, days, or weeks, it's building that personal experience. And to query that personal experience is where agent memory comes in, and that's where Cypher can be used. So here are these like 4 types of agents that we've all been using, right? There are coding agents that are IDE assistants. They're performing coding tasks. They're enabling code review boards. There are knowledge brains that you can talk to, discuss. When you're brainstorming on certain problems or doing some designing, you can work with these knowledge brains. There are team knowledge bases that are showing up as agents, right, which can have access to team docs, wikis. It can organize chats. It can also, to some extent, manage team's execution, right? And then there are these long-running agent loops. So agents that are used for specific problems like operations, support. It can also make some autonomous decisions independently, right? Like to respond to like customer queries or do some mitigations for incidents and things like that. So again, over here, you'll see the similar pattern emerges where you can recall semantically, walk through relationships, and then get the time and ranking into consideration. OK, so how Cypher helps, like we saw with GraphRag, right? There is a problem with flat memory. Vector can only retrieve similar experiences, but it doesn't understand what is connected. So there's no causal chain. So if you ask questions like what happened the last time, it doesn't know like what caused the last time, right? So it doesn't know like what is happening and how that's connected to the overall knowledge base. So agent memory also needs these combined signals: vector, text, recency, and edges. This is what Cypher on Velox enables. It unifies all signals into one comprehensive query plan with streamlined execution. And then again, in agent memory, I'd encourage you to think of building your queries like this: find, traverse, and expand. For find, you can ask questions like, user mentioned login problem. What did we discuss, right? So if you look at the query over here, we do a call into DB index vector search. And then you can have some filters specified, yield certain fields, and then you can order by, right? Now you can build on top of it to say, what caused the deployment failure that we debugged? So it can do a search, a semantic search, but it can also do a match and walk through dependencies or relationships. And then expand is, again, where you can ask broader questions, like walk me through the SEV that happened last week, right? So vector finds the starting event, and then you can expand with the edges. OK, so what's next for us? We're continuing to develop this. We're improving our graph support, adding support for more algorithms. We're doing vector search enhancements, tighter integration, and enabling hybrid retrieval. We're working on query optimization and support for more backends to expand our reach. And we're also considering making our work on Cypher on Velox open source so we can encourage more community contribution. OK, so to recap, we looked at what Cypher is, how we built it on Velox. We looked at 2 problem domains, agent memory and GraphRag, and then similar patterns across these: find, traverse, expand, and how we can write queries across these. So Abdullah and I will be right here, happy to hear what you guys are building. If you have any questions, happy to answer. And thank you so much for your time.